So today I want to look at climate apps. Climate apps meaning things related to climate change, working on climate change, citizen science projects, that sort of stuff. So as you know, on this channel, we are raising money for an endowment and we're going to spend it on open source projects and try to make the lives of some open source projects easier. Right now, the endowment is very small. You can help improve that by donating to the channel, by subscribing, by telling your friends, by becoming a Patreon patron or a channel member, any of those things. And this is Ants Are Everywhere. And so let's look at some climate projects. Now, I had some folks had asked me how I choose how I find repos, and so I thought that one thing we could do is try to search for some of these repos, because I wasn't really aware of anything that stood out to me as being the first sorts of things to look for in climate apps. And so this is a little bit of the sort of work you would do if you wanted to start an open source project of your own and you wanted to see what was out there, what's the landscape like, and that sort of thing. So let's start by what? Let's ask Chat or Gemini or ChatGPT what they suggest for climate apps. So tell me about some open source climate apps. Climate software repos that are working on climate change. And this is going to suggest some, and so at the same time I'm going to ask Gemini. They will probably say essentially the same thing. So open climate fix, I guess we'll open this. Open energy data. Drawdown, project drawdown. A lot of these seem like there may be data repositories. Climate machine. QGIS. I'm guessing that, yeah, okay, so GIS. Geographic Information System. Used for spatial analysis, which can be crucial for environmental monitoring, resource management, and climate research. OpenAQ for air quality data. It's an open source platform. Carbon footprint. I'm not so into the carbon footprinting stuff. Are any of these not really open source? I'll ask, and then they already asked Gemini. Yeah. Okay, so Gemini is kind of going in a different direction. Gemini is suggesting PyVis, a collection of Python libraries for data visualization, including geographic, meteorological, and oceanographic datasets. Cartopy. So this is for maps and stuff. Climate modeling and analysis, we have Pangeo. So this provides cloud-based computing resources and open source software for accessing and analyzing large Earth science datasets. That sounds interesting. I don't think the code for that would necessarily be very interesting, but it might be. Climate models and electricity maps. Provides real-time visualization of the CO2 emissions of electricity consumption. Liquid Prep, a solution for farmers to optimize water usage. I am guessing these are just specific applications. I don't know if this is the name of an application or if it's the name of a kind of application. Yeah. Okay. So we'll tour through these and see if there's anything we want to look at more closely. NMF.earth, reducing climate carbon footprint. There's OS Climate. and this awesome atmospheric ocean and climate science thingamajiggy. All right, so let's take a quick look through some of these. I want ChatGPT and Gemini to still be in their own tab, but now I've made my life harder, so I'm going to actually pop them both into a new frame. All right. Open Climate Fix. So this is what? This is a GitHub repo or GitHub organizations. They have 88 repositories. PVNet, data pipe for training and inference. Quartz solar forecast. I don't know what that is. Quartz front end. India forecast app. Graph weather. So these look possibly interesting. I'll bookmark this page. So they're a nonprofit product lab totally focused on reducing greenhouse gas emissions as rapidly as possible. Every part of the organization is designed to maximize climate impact. And then there's this how to get involved, but you can submit pull requests. And there's this, but it would be nice to have some sort of representation of what their repositories are. How does something, I guess, get to be a repository? Which of these repositories are getting emphasis? That sort of thing. There's 88 of them in 2 projects. The Big Solar Hunt and Open. And what? No. 1 open and 14 closed. I guess this is like some attempt at GitHub project management software. I'm not so familiar with GitHub projects. Sudo labeler, training labels and other. So this is for some sort of training data API for hosting nowcasting solar predictions. This is something for diffusion weather modeling. Can I sort these by, I guess they may be sorted by stars or something. Last pushed. So if I sort by stars, I get this PyTorch implementation of MetNet. I don't know what MetNet is. MeteorNet? State-of-the-art neural weather model. Okay. So is this open source? Okay, so this is an open source implementation. I don't know what the skillful nowcasting is. So it's some generative model of radar. With a paper, skillful precipitation nowcasting using deep generative models of radar. Is nowcasting a general thing? In meteorology, the weather forecasting for a short period of up to a few hours. Then there's 3D nowcasting. Okay, so I'll learn about nowcasting. So this seems to be some stuff for nowcasting. Let's leave this organization and look at some other stuff. Project Drawdown. We have a solutions thing. Maybe we'll look at solutions. We have some spatial AEZ. Data files research platform. And then let's sort these. How many repos? 5. Okay. I guess we'll look at a little bit at all this stuff. ClimateMachine.jl has been archived by owner. It is now read-only. Note, this repo is not currently being maintained. Please see the following repositories. And we have a bunch of smaller ones, like Oceananigans. That's a good name. Surface Fluxes sounds like it's mathy. Cloud Microphysics, Thermodynamics, Clima-Atmos. I'm guessing this is a combination of climate and Atmos, the chip company, and Climate Core. Yeah. I think they said that this was the MIT thing. Climate Machine. Climate Time Machine. I think that's different from Hot Tub Time Machine and also from Climate Machine. So Climate Machine looks like Caltech. I thought somebody told me it was MIT. Caltech, MIT, and NASA's Jet Propulsion Laboratory. So this is really a West Coast thing. Oh, Caltech. Why did I think MIT? Did I just translate Caltech to MIT in my brain? Okay. So this is the Caltech thing, and that's cool. That we'll delete that old repository though. So QGIS, this should be some geographic spatial stuff, which we haven't looked at any geographic GIS stuff yet. But this is maybe less climate-y and more map visualization-y. A free open source cross-platform geographical information system. And that's probably important, I would guess. Some of this is 19 years ago, is that right? Exception to GPL for Qt. So that's maybe some something about the Qt licensing. Beautiful cartography. All right. Support for raster, vector, mesh, and cloud point data in a range of industry standard formats. Raster formats include GeoPackage, GeoTIFF, GRASS, etc., etc. Okay. And they have support for point clouds. That's all fine, but we're going to ignore it. Open AQ API. This should be open air quality. I'm guessing that OpenAQ is providing the API, and this is really just like a REST API for or like for clients as opposed to the server. Deployment is managed with Amazon Web Services. In production, OpenAQ API runs on AWS Lambda. Okay, so they've got the serverless. I don't know what Magnum is. Magnum.io. Okay, whatever. All right, so maybe this is for serving the API, but I don't know what OpenAQ is. Open platform for air quality data. Okay, so these are the APIs, but where's the data? You can fetch stuff, you can explore stuff, and there's this list of awesome air quality stuff. Let's see. Okay, open air quality. Some software libraries. Oh, I think this is mainly for handling the data. So let's see if we can find out whether it's really open source or not. So I'll ask, is the OpenAQ data publicly available in bulk? Okay, so it seems like ChatGPT says that they're available in bulk. and we can, so they have this explore the data thing, which I'm guessing is like a web-based data explorer thing. Choose any pollutant. How about ozone? That's ozone, right? I think ozone is O3. So, yeah. Well, can I move this thing? It would be nice if I could move this out of the way. How do I get to, okay, so here's the US. It's basically all the population centers, I would assume. Not much in China or Russia or Africa. Some on the coast of Australia and lots in the United Kingdom. I'm wondering if this is really a map of where the monitors are. In fact, I bet all of the, yeah, okay. So what does that tell us? I'm not sure. Here's Deutschland. How about Belgium? Belgique? Is this just telling us that there's a sensor here in Ghent? It's a reference grade type. I guess that's a like a high quality sensor. I assume it's saying. Last updated 2 hours ago. So these are not like continuous. This is not like continuous. It's once every few hours or so. And it is reporting a bunch of stuff, including NO2, CO. This is what, micrograms per cubic meter. And there are no recent measurements for some of these, I guess. And they give us the trend line. The trend line is cool. Seems like O3 is descending, as are many of the things. So where are things maybe not descending? How about the American South? They don't believe in climate change there, I think. So O3 is descending. I think O3 is probably descending around the globe. What is PM10 and PM2.5? Was that 2.5 or did I misread the comma? Particulate matter. Okay, so this is some measure of particulate matter, probably including things like, okay, so 10 is 10 micrometers and smaller, and PM2.5 are fine inhalable particles with diameters that are generally 2.5 micrometers and smaller. So the average human hair is 70 micrometers in diameter. Okay, cool. I don't know, like, so gas stoves, particulate particles. I mean, that's redundant, right? But I would like, okay, so this seems to be telling me cooking with gas stoves creates nitrogen dioxide and releases additional tiny airborne particles known as PM2.5. Okay, so that's just useful to know. And then what is PM10 particle examples? So PM90 is fine beach sand, which you can use to make sand sculptures. This PM50 to 70 is human hair. PM10 is like dust, I guess. And here's some more. Organic matter, organic carbon, sugars, soot, metalloids, soil dust, sea salt. Are we breathing in sea salt? How is that even possible? Okay. So that's so those are increasing, the 2.5s, or well, they were increasing for a while, and they're going down. And CO is static. Where else can we look at? That was what, Jackson, Mississippi? How about Orlando, Florida, where Mickey Mouse lives? Okay. These mostly seem flat. How about in Mexico? There's not a lot of recent measurements here. How about Colombia? Okay, so we don't have the PM10s are like spiking here, but we don't have the PM 2.5s. And then is there anything in Africa? Nobody, well, what's this? I actually don't know what these islands are. Is this Las Palmas? All right, so, okay. Just, so some data. And there's some stuff about why open data. And then they have some APIs for accessing it. Okay, so that's somewhat interesting. Actually, pretty interesting. Here's Carbon Calculator. I don't know what that is, but it doesn't seem to exist. Pangeo promotes open, reproducible, and scalable science. Blah, 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 provides documentation, develops, maintains, and software deploys it, blah, blah, blah. Dask, Jupyter. Some seems Python-y, but what do they do? There's some gallery and some stuff for scientists. Let's open the gallery in the same tab. Okay. So I don't know. Oh, glaciology, for sure. For sure. Can I click on this? Is there a repo? Yeah. Okay, so there's notebooks. How about Antarctic bed and surface digital elevation model data? Yes, that's what you want, because then you can use this elevation data to create your Antarctica game levels for so having a realistic Antarctica level. So this, I guess, is some sort of depth map of this surface. This is ice thickness. Okay, and then there's a bunch of Python. The main thing they're going to do is they're going to load some data set, and then there will be routines from the field of modeling stuff, and they're probably going to use some combination of NumPy and pandas and maybe SciPy. Where are the imports? NumPy, Xarray, Matplotlib. Okay, cool. Liquid Prep is what? End-to-end solution for farmers who want to optimize their water usage, especially during times of drought. This is, I think, pretty cool. And we get some sort of map. So IBM Cloud, I guess maybe IBM sponsors them or donates cloud computing. The weather company, is that an IBM company? I think it may be. The Weather Company LLC is a weather forecasting. Oh no, are these the people that own the Weather Channel? Parent is NBC Universal. Subsidiaries Weather Underground and probably weather.com, right? Operates weather.com. Okay, great. So I guess basically they're pulling stuff down from weather.com. And cloud function, I'm going to guess, is a Lambda in AWS. Lambda and not a function of the clouds that are up in the sky. Cloud Ant DB. I like that there's ants involved. CloudInt is an IBM software product which is primarily delivered as a cloud-based service. It's some database, it looks like, based on CouchDB. Okay, so this is cloud in the sense of large computers, not in the sense of droplets of water in the sky. And there's some front end, which has some object storage like AWS, and a progressive web app, things you do not at all care about if you're a farmer. Nobody cares about this, IBM. I feel like IBM is trying to tell me that it's qualified to take a junior DevOps role. Okay, so then some users have some Liquid Prep app and some sensor module, which has a microcontroller and a soil sensor. And so it's going to somehow use the sensors, the local information, Arduino. It's going to somehow use the local information about your soil, and really that's it, right? We have one sensor and one microcontroller. So it's going to use information about your soil, maybe stuff like dryness. I don't know if it's going to measure things like nitrogen, and it's going to send Bluetooth information to your phone. Do you have one sensor? Or do you have like 100 sensors throughout your field. And at any rate, it's going to tell your phone, I guess, how much water it needs. And then your phone is going to look up on the weather channel when it's going to rain, I think is essentially what's going on. And it's going to tell you whether you need to run the sprinkler or not. But like the big farm sprinkler, not the little kid sprinkler. So this is possibly interesting. I'm going to bookmark this. I don't know if the code is interesting because this looks actually really simple. But I think this is I thought this was going to be maybe more like how data centers manage their cooling, which is, I think, via some online reinforcement learning type model that is continuously figuring out where things need to go. I think this is more like, is it going to rain? And if so, do I need to turn on the sprinkler? But I'm gonna pop this into its own thing, and we'll see if there's anything to dig into there. Okay, OS Climate. Bloomberg LP has joined the community of leaders. Okay, but what is it? It's got some link to the Linux Foundation projects. Maybe this is one of the Linux Foundation projects. How about visions and goals? Establishing an open source collaboration community to build a data and software platform that will dramatically boost capital flows into climate change mitigation and resilience. I'll add this to Wallabag. It's mostly, this tells us a little bit, right? So it's they want to build a community. It's based around open source, and they want global capital flows into not just any climate change stuff, well, specifically mitigation and resilience through a nonprofit, non-competitive organization. Okay. The best they'll aggregate the data, modeling, and computing and data science worldwide into an AI enhanced physical economic model that functions like an operating system. It will not function like an operating system, but it will be a physical economic model enabling powerful applications for climate integrated investing in a world where the future will be very different from the past. Okay, so this is somehow focused on capital and investing. And they want to build a model. I don't know why the Linux Foundation is involved. This kind of seems like they're crowdsourcing information that'll be of interest to hedge funds. Is that what they're doing? The problem. Okay, so then they have projects governance. Should we look at governance? There's some governing board, outreach, legal, and budget. Okay. Portfolio alignment. So all of this is mildly interesting. I'm going to share this with some folks that are in this space. But I don't know if there's much code. We have Data Commons portfolio alignment tools. This is maybe a screenshot of something. We've got some filters over here. These are, this looks like maybe a dashboard, that an executive might see. Portfolio level temperature rating of selected companies. Okay, so this is some data visualization dashboard, it looks like. Then we have enterprise value, including cash of selected portfolio, and so on. For what? So I guess you have some investment portfolio. What is this? This is the OS climate thing. Okay. So that's mildly interesting, but it's kind of a weird positioning. I see what the need for it is, but I don't think that's what we're here for. What else do we have? Open Energy Family. The Open Energy Academy is a collection of courses, tutorials, and questions for the Open Energy family. Okay, and then they have some ontology. And then let's look at their repos by stars. So their most biggest repo is the ontology. They have open master. So a collaborative software to download the energy database Mark Stammdaten Register. I don't remember how G's are pronounced. That looks Germanish or Dutchish. OE platform. Awesome. Sustainability technology. Okay. I don't really have a sense of what these people are up to. Oh, they are in Germany. They're dedicated to discussions and decisions regarding the open energy family. Oh, rather the repository is. Okay. All right. I really don't know what the open energy family is about. Maybe this is not the right entry point for it. Oh, not open entry. It seems like it's related to open energy platform. Scenario bundles. Do you want to learn more about scenarios? The models used to project them and the actual data? Yes, I do. And they have some database. Am I interested in data? Kind of. I'm more interested in scenarios. All right, so what are some scenarios? Are they in German? Yeah. The full name is Aktuell Maßnahmen Szenario. In this scenario, all measures that were implemented in Germany until October 2012 are taken into account and are extrapolated to 2050. This scenario reflects the current status of energy, AN, and climate policy framework. I'm guessing that is a typo. And I'm hoping that some of this is in English, but this seems like they're just basically doing a linear model and calling it a scenario. And I guess it has lots of like metadata so that you can search through your models, I guess, and find information about different scenarios. The scenario type is with existing measures scenario. So I guess it's based on real measurements, and it's a policy scenario. And if I click on this, maybe I can see other policy scenarios. Okay. Pretty cool. And here's the Academy thing. I don't know if this is going to be so interesting. In fact, I'm not going to look at it. And the ontology is, I'm just mainly curious what it's written in. It makes use of the basic formal ontology. Okay, and how does it work? Is it just we have all the ontology in a bunch of files? Edits, imports, OMN. We have OWL files. So we have like Daniel Schober is a person, and these are presumably basically RDF triples of some sort. And triples. I don't know about RDF. Okay, so here's open source quartz solar forecast. An open source PV forecast. I'm not sure I know what PV is. That is free and easy to use. The forecast provides the expected generation in kW for 0 to 48 hours for a single PV site, photovoltaic maybe. Open Climate Fix also provides a commercial PV forecast. We recently presented the Quartz Solar Forecast Project. So I guess probably quartz is used in photovoltaics, right? They've got some dashboards. Yeah, it must be photovoltaic because it's called solar. Here's diffusion weather from Open Climate Fix. And we've got, so pre-trained weights are coming soon. We plan to train a model on GFS 0.25 degree operational forecasts. Okay. So this, I think, is mainly like let's see what's inside. We have some data, or at least we have a folder for data. And we have something in models, I hope. Is there anything? Is there anything? Is there anything in this repo? Is it in the init.py? What is going on? We have workflows, we have tests, and some requirements. And we have test model.py. Add empty structure 2 years ago. This is the craziest Git repo I've ever seen. There seems to be nothing there. Okay, here's MetNet, which is some PyTorch implementation of some like Google archive paper, I think. MetNet and MetNet 2. I thought we were on MetNet 3. MetNet 3, state-of-the-art neural weather model available in Google something or other, in Google products. Okay, so you can access the model, and I'm guessing that Google's state-of-the-art is one generation ahead, I guess, of this open source implementation. While the exact training data used for both MetNet and MetNet 2 haven't been released, the papers do go into some detail as to the inputs, which were GOES16 and MRMS precipitation data, as well as the time period covered. So they're using, I guess, open or publicly available data sets. I don't know if that link is broken or if you have to log in to see them. But and I guess the model, the paper probably gives you enough information about how the model was trained in order to replicate the training. And so I guess here's how to use it. You say MetNet, and you set forecasting steps to 8. Input size is 64. Number of input time steps 6. I don't know what these numbers mean. 8, 64, and 128, 32. These are all powers of 2, of course. Powers of, they all have 8 as a factor. These could be like bytes. MetNet expects original HXW to be 4x the input size. Okay, and so this is some presumably size of panel data or tensor or something. And then this MetNet 2 object is the thing that holds the model. Let's see if we can see its implementation. We've got some image encoder, which is just a string set to downsampler. I feel like we've seen this somewhere. I don't think it was in the PyTorch, but maybe it was in the PyTorch. Hello, how am I doing? I'm doing well. Hello, Justin. How are you doing, Justin? I'm doing well, aside for my audio equipment not behaving. And Linux generally not behaving, but I've come to expect that. Okay, so we've got input channels. I forget how channels work in PyTorch. They have some sort of input and output. Input size, LSTM channels. This should be long short-term memory. I don't know if it's a channel or I thought it was like a way of combining neural networks. Long short-term memory is a type of recurrent neural network aimed at dealing with the vanishing gradient problem present in traditional RNNs. Its relative insensitivity to gap length is its advantage over other RNNs, hidden Markov models, and other sequence learning methods. So I guess it's just from context, I think maybe it's about learning sequences. And something about gap length. like some distance, maybe length of the sequence, maybe distance between sequences or something. And it's trying to deal with vanishing gradient, which is where the gradient becomes small, I guess, and you don't know where to take the next step, since the gradient is used as a pointer of where to go next. Just like in what is it, Newton's method? In numerical analysis, Newton's method. Blah, 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 blah. Named after Newton and Raphson. I forgot about Raphson. Is a root finding algorithm that produces successively better approximations to the roots of a real valued function. The most basic version starts with a real valued function f, its derivative f prime, and an initial guess x0 for a root of f. And so we set the guess x1 to the initial guess, and we're going to subtract off the quotient of f with its derivative. Geometrically, x10 is the x-intercept of the tangent of the graph of f. Okay, so here, here's our initial guess, and then here's the tangent, and we go along the tangent, which is like the one-dimensional gradient, and we find out where it intersects the x-axis, and that's our, and we kind of project it back up onto f, I suppose. Or rather, I guess we just care about x. This is just f of x. So that's Newton's method. Vanishing gradient, I guess the idea is that if the gradient becomes small, then you won't know where to go next. In machine learning, the vanishing gradient problem is encountered when training neural networks with gradient-based learning methods and backpropagation. Blah, 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 blah. The problem is that as the sequence length increases, maybe I should read this sentence. In such methods, during each iteration of training, each of the neural network weights receives an update proportional to the partial derivative of the error function with respect to the current weight. So as the sequence length increases, the gradient magnitude typically is expected to decrease or grow uncontrollably, slowing the training process. I don't know if there's like a good calculus intuition in this, but certainly in numerical computing, like the more you do something iteratively, even if you have small errors, they tend to grow. So just the general thing of numerical methods kind of having some unstable error issues is really common. In the worst case, this may completely stop the neural network from further training. As an example, so some of these activation functions have gradients in the -1 to 1 range, and backpropagation computes the gradients via the chain rule, and so you end up multiplying n of these small numbers, small in absolute value, as in close to 0, meaning that the gradient error signal decreases exponentially with n, while the early layers train very slowly. Okay, so you're multiplying a lot of error-y things that are small in absolute value, and you get something really, really small. And this is just the space of finite sequences. But what does that have to do with the sequence length? I'm guessing this is possibly just referring to sequence of what, though? I think that they mean like the dimension potentially. If you have like if you have a 100 dimensional gradient. I'll ask the AIs. How about in vanishing gradients? What is the sequence length? So ChatGPT is saying, okay, so this is in recurrent neural networks. The sequence length refers to the length of the input sequence, which could be a series of time steps, words in a sentence, or any other sequential data points. I'll ask, is this different from any different from the dimension of the input vector? So ChatGPT is saying it is different. The sequence length would be the number of words in a sentence, etc. The dimension of the input vector refers to the size of the vector that represents each element or step in the sequence. For example, if you're processing a sequence of words where each word is represented by a 300-dimensional word embedding, then the dimension of the input vector is 300. Okay. I still think that's dimension, but they're dimensions of different things. Okay, that's fine. Fair enough. Okay, so, and then I guess while we're here, let's remind ourselves what backpropagation is, in case, like me, you've forgotten. I mean, I know it's about taking the output and propagating it back over the previous layers. Is a gradient, so backpropagation is a gradient estimation method commonly used for training neural networks, blah, blah, blah. It is an efficient application of the chain rule to neural networks. Backpropagation computes the gradient of a loss function with respect to weights of the network for a single input-output example and does so efficiently. I want to know what it does. So it, strictly speaking, the term backpropagation refers only to an algorithm for efficiently computing the gradient, not how the gradient is used. But the term is also used loosely to refer to the entire learning algorithm. Okay. So we compute a gradient in weight space of a feed-forward neural network with respect to a loss function. So weight space is just the same as a parameter space. Feed-forward means that we don't have a feedback, right? And then we have an input, out, target, loss function, etc. This is like too technical, and the intro is too general. I'll ask just what's up with backpropagation. I'll ask what's backpropagation in mathematical terms. So we have some forward pass, and then some loss function. So backpropagation computes the gradients of the loss function L with respect to the weights and biases using the chain rule. For the final layer L, the del L del A to the L. I don't know what A to the L is. That's maybe an index into L into A. Activations from the previous layers. I think that's supposed to be an index. Is the change in L with respect to Y, which is the difference between Y and Y true. And then we propagate the gradient backwards. So the change in L with respect to Z of L is the change in L with respect to A. The Lth element of A is how I'm going to interpret this times the f prime of Z of L. And what is Z? Z is, we've taken the weight matrix, multiplied it by the previous activation, and we've added this this like I want to say constant term, but this is this is y equals mx plus, what is it, mx plus b. So this is the intercept. But what is so b is some bias vector. Okay. And so Z is just after we do the affine transformation of the previous activation, I guess. And then presumably we have some squashing function that unlinear that allows for nonlinearities. Okay. So I guess it just does seem like the chain rule. I'm not sure exactly how that defeats the vanishing gradients, but I guess we're not just like taking a bunch of stuff and multiplying them. It seems like maybe we're going back closer to first principles and computing it with another method. And I don't know. So it does So does backpropagation help with vanishing gradient because of numerical instability? Or is there some other reason? So backpropagation itself does not solve the vanishing gradient problem. In fact, it's the process where the vanishing gradient problem becomes evident. Oh, okay. So as you propagate the error backwards through the network, the gradients of the loss function with respect to the weights are calculated. This involves multiplying gradients layer by layer. And then we have activation functions, blah, blah. Yeah. So what were we looking at that was, that was telling us it solved the long short-term memory? Is that what it is? Okay. All right. So at any rate, we have this long short-term memory stuff. And they have some equations. And there's some stuff about forgetting gates. So we have, okay. So I'm going to read this offline because we've already derailed enough into this territory. And this is all basic stuff for anyone who's worked in AI for the last, decade or so or more? When was this from? Oh, not so old. 2018. Bill Gates called it a huge milestone in advancing artificial intelligence. Okay. Well, yeah, all right. Okay, so we have some LSTM channels. I'm guessing these are like LSTM units, but maybe they can send messages. Encoder channels, upsamplers, etc., etc. And then what? So this builds on MNNet 1 to use an even larger context area to predict up to 12 hours ahead. It differs from the original MetNet in terms of the axial attention. In terms of the axial attention is dropped and there is more diluted convolutions instead. Okay. And this is just like setting up. This is like plugging things into a patch bay essentially. This is more setup. This seems to be more setup. This is pretty verbose. Here seems to be creating something. So it's presumably a convolutional LSTM. A conv LSTM with 13 time steps, 128 LSTM channels, 18 encoder blocks, etc., etc. Okay, and then we have modules. Modules, I think, are really fundamental to PyTorch, if I am understanding correctly. And I don't know, some block of stuff. Dilated residual conv. Okay, so this is a whole thing that I think if you do machine learning, you know all of the different convolutional whatchamajiggets, and you like wire them up to each other. And then you have some forward step that is usually, I think, seems pretty simple once you've wired all the layers. Okay, so that was that again. That was MetNet. And it's forecasting some sort of meteorological data. I don't know why I can't say that word today. Or maybe I can never say it and I just don't ever try. Okay, so I think this was for nowcasting. Is that right? Let's double check what we are forecasting. Short-term weather forecasting. Okay, so here's skillful nowcasting with a deep generative model of radar. So this is an implementation of the paper from DeepMind. That's also a cool thing. It's nice to have open source versions of these models. This is the paper. Is this worth reading? If it's less than 10 pages, I'll read it. If it's more than 10 pages, I will. 46 pages. But how many of those are appendices? So Appendix A starts on page 29. I mean, maybe it's a cool paper. Yeah, I'll read it. Okay. Here's the Project Drawdown solutions. The mission of Project Drawdown is to help the world reach drawdown, the point in the future where levels of greenhouse gases in the atmosphere stop climbing and start to steadily decline, thereby stopping catastrophic climate change as quickly and safely as possible. Okay, but what are we doing? So there's some book. The Project Drawdown models are, at their core, economic models which estimate the total global and regional demand for each solution and the percentage of that demand each year which might adopt the drawdown solution. So they have some drawdown solution, currently unspecified or probably specified in the book, but I am currently ignorant of it. And they're really just forecasting the demand, it seems like, for their solution. Is this just straight up demand forecasting? The monetary and emissions impacts of that adoption are then calculated. The framework and methodology for the model was developed by a core research team at Project Drawdown with senior research fellows and visiting researchers from each of the relevant solution domains. Okay. I don't know what a PDME is. Yeah, but we do have some code. I don't know what the code does. It's got some data. Normally I don't look at the data directory, but this seems to be a heavily data-driven project. So we have ocean allocation, which is somewhat like a, is this an Excel spreadsheet? I think. Okay, so we have world, blooms, deserts, equator, ice. How about ice.csv? And we have things like Eastern Europe has a certain total area in MHA, millihectares, megahectares. I had no idea. I had totally forgotten that the hectare was a metric unit. It's a non-SI metric unit of area. Is the only SI metric square meters? Yeah, you would think. So why not use square meters? Okay, so we have some total area. We have DES1, epipelagic, mesopelagic, and bathypelagic. Are these like terms in, what would it be? Not genealogy, the zones of the Earth. Okay, so these are parts of the ocean. And where are the anglerfish? The benthic division. So here's the anglerfish. they're in the bathypelagic zone, I guess. And squids are in the mesopelagic zone. And as are octopodes, octopodes. And the squids can go down here. These are some kind of whale. Is that a blue whale? A blue whale looks like this with a beard. I think that's a blue whale. I don't know what this is it pelagic or pelagic? What animals live in the bath yawl? I'm gonna take a bath yawl. This is Bathel, but this is bath yawl. So we've got eels, crustaceans, squid, whales. No whale species live permanently in the Bathel zone, but sperm whales, with the large proportion of tissue in their heads protecting them from the immense pressures at depth, are capable of diving into the Bathel zone. Okay. Yep, that's a sperm whale, I guess. Cool. All right, so you can order your Whales of the World poster. And these are different zones. And they have recordings, I guess, of what? Ice. Maybe? I don't know how you get ice that deep. But maybe it just means... Wait, where was that? Was that Europe? Let's find a place with lots of... So, yeah, Eastern Europe. Maybe close to the Arctic. Like up here. And what about Greenland? Does that count as... And what's OECD 90? Maybe, so the OECD is some organization, and OECD 90, I'm guessing, is a region. What if I look up OECD regions? This doesn't seem to be. Well, maybe if I download the PDF. This is going to be a big PDF. I just want to know what, how about I just ask ChatGPT, what's OECD 90? And it's just going to search the internet. A group of countries that were members of blah, blah, as of 1990. Oh, okay. I thought it was going to be like, I thought they were going to be numbered regions of the globe. So I don't know how to find Greenland. Maybe, where's the US? Is it considered, I don't know. Okay, so that's ice. Whatever blooms are probably algae blooms. And so on and so forth. Okay, so we have some data. That's ocean data. We have also like energy data. So, and these are divided into drawdown scenarios. How about we just pick on scenario 3? I don't know what these numbers are, but there's some measurement. These are obviously years. And presumably these are just projections. And we have limbo. Is limbo where software is in limbo, or is limbo where like the earth is in limbo? These have things like, so there's some dashboards, some graphal, which is maybe omnigraphal related. Some vector graphic stuff. Solution. Let's look at solution. Airplanes. Yeah, why not airplanes? I don't know what any of these are. TAM tests VMA data, AC, and these are like JSON files. So this is mostly data, it looks like. Let's see if there's anything in the airplanes directory that's not a data file. CSV, CSV, CSV. In tests, we have some, we can test airplanes. And we're going to load solutions, and we're asserting that we can load them. This is more loading and in testing, I guess. Key results tester. Okay, so I have no idea really what is going on in this repo. This seems to be mostly data. They've made some projections, and they're keeping track of some data, and they're making it available. And GitHub is doing the hosting. We do have some Python in integrations. Food system emissions and yield. This is some IPython notebook thing. I don't remember how IPython notebook is different from Jupyter. So we have countries.txt, a static list of 98 countries. We're importing pandas, pathlib, and we're checking if the country exists, it looks like. And here's some information about the model. Food supply, waste, and demand in the reference scenario are based on the most recent comprehensive food supply data available in a recent global food demand forecast from Alexandratos et al. In 2012. That may have changed significantly. First of all, the climate has changed significantly. Second of all, we had the pandemic. I don't know globally how many people died. This is by country, but maybe they have a total world. 876 million. Deaths per million. Oh, no, okay. So 7 million. That's not that's a lot of people, but that's maybe not going to change the global food demand situation. Okay. The original forecast applies only through 2050. However, we assume that trends from 2030 to 2050 continue until 2060. And we've got some baseline data. Blah, 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 blah. And there's some framework. We have some theoretical maximum supply that feeds into a farm gate supply. LCA emissions factors apply to these values to estimate emissions. And then we have some production waste. So I guess we estimate, we can grow this much corn or whatever. I'll just assume everything is corn because I live in the USA. So we grow maximum corn. Some amount of that is waste from like bugs or, as you send tractors out to harvest it, some amount, I guess, is wasted. Some might spoil. And so I guess theoretical max might be like we literally take farmland area and multiply by some yield estimate. And then there's some waste and some farm gate supply. I don't know what that means. We have handling, processing, packaging, distribution. I guess this is measuring energy. And then there's some supply chain waste. And then there's FAO supply, post-distribution. There's some consumer waste, and there's some, and then we get consumption/demand. Caloric intake in plant-rich diet affects these values. Okay, and so this is just some model. We're just adding this stuff together. And we get some equations. And we're reading a CSV file. And monkeying around with the data to get it in the right format. And just basically, this is just like data massaging, it looks like. I'm sure we have this supply sum thing somewhere. I don't really see it, but maybe there's a call to, maybe we're just calling sum on some columns or something. And then we, LCA emissions by product, we're reading another CSV file. We're reading a CSV file to get the population estimates. And then maybe after we've read all the data in, this is maybe where we finally do computation. We're gonna set demand to be the supply minus the waste. So somewhere we must have computed waste by doing this stuff. We're re-indexing and just setting it to columns, it looks like. And then we have what looks like we're setting up for a model. DF is maybe some sort of derivative. And we have some parameters, localization emissions, reduction percentage. These are put into the model rather than being estimated in the data files. The diet year start, the diet year end, waste start year. I don't know what diet is. Okay, plant-rich diet. And then we do read some stuff in. Maybe these parameters are just to tell us what to reach in rather than being parameters of the model itself in like a mathematical sense, and so on and so forth. At some point we must do some computation, I would think. But that's what this notebook is about. And that's part of the project drawdown stuff. Here's spatial AEZ. This is for processing spatial climate maps. It extracts land area data from spatial maps for use in climate solution modeling. Okay. It comes from external sources and so on and so forth. So this is essentially going to pull in data, probably put together some existing mapping libraries, possibly Python driven, and possibly GIS stuff. Oceananigans. So Oceananigans is like fluid dynamics, similar, I would guess, to what is it called? Open foam. I do want to see this, but I'm going to pull it out and try to get to the end of some of this other stuff. Except that we have climate surface modeling next. And that's also seems like PDE type stuff. Here's cloud microphysics. I guess .jl is what, Julia? A package containing a library of cloud microphysics and aerosol parameterizations. Okay, so I think the other stuff we have is Julia. Here's some thermodynamic stuff. Moist thermodynamics. I kind of want to keep this in a bookmark. Clima atmos is what? What? Oh, atmosphere. I don't know why I decided it was Atmos. Am I getting that right, that there's a chip company? Maybe Atmel. I'm thinking of Atmel. I think, right? Atmel? Yeah. All right, well. Okay, so this is some atmosphere thing. What about the atmosphere? Yeah, so far this seems like maybe the most interesting project to me from a coding point of view in terms of what we can learn about their code. Because all of this climate stuff, is this Climate Machine? I forget what CLIMA stands for. Climate Modeling Alliance, an alliance of scientists, engineers, and applied mathematicians dedicated to pioneering a new, data-informed approach to climate modeling. So this stuff looks really cool. This is the Caltech stuff. Is it? What? I thought Caltech was also Climate Machine. Oh, Climate Machine is MIT. I'm all confused. So there's Climate Machine by Caltech. What about Clima? Okay, so Climate Machine seems to be somehow a sub-project of Clima. But it's not clickable, so I don't know how I can learn more about Climate Machine in the next 2 seconds, so I guess I won't. Okay, so this Clima stuff looks good. They are using Julia, which I'm not sure if it's like for a while people were really into Julia, and then it seems like people are talking about it less. I saw some article that I think was by Dan Liu, where he wasn't like super impressed with the Julia ecosystem or the maintainers or whatever. Like they were ignoring important bugs and stuff. 2024 may be the year for Julia. And I actually don't know like when it was started or really even why. High level, general purpose, dynamic programming languages. Most commonly used for numerical analysis. So I kind of personally think that Python sucks. For that's way too strong. I don't like using it. I like if I have to do data stuff, I prefer working in R. In practice, I work in Python because that's where the libraries are. But as a language, I don't enjoy it so much. So maybe that's part of what's going on with Julia. That it's like supposed to be an alternative. It appeared in 2012, but by 2012, like I feel like Python had already taken over. Set out to create a free language that was both high level and fast. Maybe Python was just slow. I'll ask ChatGPT. What is the value proposition of Julia over Python? So they're saying that it's slower, so Python is slower. Okay, well, I think that there's people trying to improve the speed of Python. So I'm not sure how important that is, and that a lot of stuff is being offloaded onto the GPU. And so I don't think Python is usually the bottleneck there. So I'm not sure. All of this is me wondering aloud that it seems like the Clima people have heavily invested in Julia. And I'm wondering if that's limiting the ability to to reach other people. Brother, what is the motivation of these streams? I don't know. Just fun. The motivation of this particular stream is I'm looking at climate software and trying to see what the ecosystem is like. All right, so I like these climate people. I think Julia is fine, and their models, their repos seem really interesting. And I don't know if we're gonna dig into any one of them, but let's step our toe in one of them. How about Oceananigans? incompressible fluids. So let's just kind of see. So there's some paper. Presumably this is like a research paper. Or, okay, the paper is in markdown format. And fast and friendly. High resolution simulations in idealized geometries. So simple geometries, direct numerical simulation, large eddy simulation, arbitrary numbers of active and passive tracers. I don't know what active and passive tracers are. Maybe that's like you put I'm going to imagine, or like a radioactive drop of water or something, and you can like trace where it flows. And I guess in software, it's a similar principle that you pick out some region or some like pixel, and you find its orbit under the transformations. So here's a large eddy simulation of small-scale oceanic boundary layer turbulence forced by a surface cooling in a horizontally periodic domain using 256 cubed grid points. Okay, so that's what they're up to. The geometry is really simplified. I don't know that. It seems like for fluids, the difficulty is often the geometry, and we have a lot of folders here, maybe more than I would have expected. So perhaps there's not some lower level library doing a lot of the work. We have things like fields, forces, grids, immersed boundaries, and some models. And I'm going to go in a couple of minutes, but I just kind of want to get a feel for what's some of the stuff in here. So we have an advection.jl, which is capitalized, and then everything else is not capitalized. I don't know if capitalized means something about public versus private. And we have things like multi-dimensional reconstruction, momentum, advection operators. Let's look at that. I'm just kind of curious, like how many lines, a small number of lines. Maybe the thing in Julia is like large numbers of small files or something. Or maybe this is just a particular style. Or maybe I just happen to have picked a file that's on the smaller size. Okay, so whatever this is some inline. I guess this will inline the function, presumably. And it's some advective momentum flux U sub U. And then we have V sub U and W sub U. Maybe U, V, and W are the 3 dimensions. And this, I guess, is this. It's setting this underscore thing to this, and I'm guessing that this is implemented possibly in the file. Oops. Here's div VU. Calculate the advection of momentum in the x direction using the conservative form this. Okay. So this is calling the underscored version. I don't know where the non-underscored version is. But I just don't know anything about Julia. So this looks good to me. If I knew Julia, I think this looks really clean. This file is a little bit longer. But you can tell that somehow all of this is putting together some mathematical, some model of the mathematical equation, and the mapping to the mathematics, it looks really clear. All of the things are named such that it would be clear what they're doing. The code is readable, and so on and so forth. So compared to, for example, OpenFOAM. So OpenFOAM, like, it seems to be really awesome. People are using it to do really awesome things. But at least when I was looking at the code, it was hard to figure out where the math was. And the math is just kind of like right there. So it's a little bit, if you're the sort of person who wanted to learn about like computational fluid dynamics, this seems like it would be a good repo to do it in. And I bet all the Clima repos are similar in quality. I had wanted to look at some of the like the open collective people who are working on climate change. But I think I'm going to call it a day here and head off. And I'll be back Monday through Thursday on the Ant Farm channel, which is now where the coding streams are. And that's where I will be building and designing software. So if you like to see things that are being built, usually on this stream, we like dig into a code repository. We didn't really go deep into any one this time. This was more about figuring out what the maybe like the competitive landscape was like. And we may choose some of these to dig into, possibly some of the climate stuff, possibly some of the more policy or data oriented stuff, but that remains to be seen. And if you want to make a request for a video, the way that we're doing requests these days is they're based on donations. So if you want your vote to count, you can hop over onto the Discord and either donate using YouTube or Patreon or I think that's about it. All right, so that's all for now. Thanks for watching.